one talk now. No one talk. Okay. And again, we're back to more like Unit 1, where you read a problem and you shouldn't be thinking, okay, I've done one like this before, how do I do this one? You should be thinking what concepts you encounter as you read the problem. So here's the flashcard ideas that come to my mind. They should come to your mind as well. If they're not, you should be making flashcards so that they become a part of your flashcard memory. So I read the words. An equation of the line. Okay? Right there prompts a flashcard memory, a really quick one. So this idea should come to your mind. If not, you should create a flashcard. You can write the equation of any line using this formula. So any line and you should also remember that m represents the slope of that line. The slope of a line never changes, so it's the slope anywhere on the line. x1, y1 is a point anywhere on the line. A line will have an infinite number of points. This is simply one of them. Does anyone need me to repeat anything about this? Like if that isn't coming to mind, you should build a flashcard. Or if you have another memory system, do that. But anyway, question. So that's one concept I'm going to need. So I set that concept aside and keep reading. Equation of a line normal to a graph. Next flashcard memory. I don't usually know what the graphs look like without a calculator. So I just always draw the same picture. So there's my graph. Normal to a graph means this. So let's see, green works good. So here's a line that is tangent to a graph. Normal to a graph would look like this. So that's a second flashcard memory you need to have. Yes, let me get some more. You're out of flashcards. Anybody else? Anybody else? Okay. Keep reading. Okay, one other thing. When you see, look, when you see an equation, you should be thinking points, infinite number of points. When you see this purple curve, you should be thinking infinite number of points. So this equation is how we find any of the points on the purple curve. Questions? The point right here is x equal 1. I don't currently know the y coordinate. Hey, in this unit, as well as the rest of the year, you have to practice looking at a problem as a big picture, and then you sometimes have to do some little tasks. But then you have to focus big picture again, please.
Is it not x equals -1?
Thank you. To Froa. Okay. So hands up. What is the big picture? What are we trying to accomplish? And they've given a bunch of information. I'm remembering some flashcards based on what I read. But what is the goal? Hands, come on. What's the big picture goal?
Find the equation of that red line.
Perfect. I need the equation of the red line. So the connections I make conceptually are here's the equation for any line. So I can use this to write the equation of the red line. I'm going to need the slope of the red line, and I'm going to need a point on the red line. So 2 points for Tommy. Raise your hand and tell me, how do I find the point that is on the red line? Hands, come on. Okay, everybody. How do I find the point that is on the red line? Hannah.
You use the equation they gave us and plug in -1 for x.
Perfect. So I come up here. I say y is going to equal -1 cubed so keep going. Make sure you use parentheses when you take away the x, otherwise you'll make a mistake. So, how many new? Oh, sorry. Please.
Hi.
Read it for me.
Okay. So then I could
Okay. Who knew we were supposed to do this before she said it? 0.2 for Hannah. What does the -6 represent? Hands, everybody. What is the negative? Think with me. Don't just walk. Think with me. What does the -6 represent, Jane? Y coordinate. So right here. And now I know that this point, -1, -6, is on 3 different things. It's on the purple curve, it's on the green line, it's also on the red line. They all intersect at that point. You need me to explain anything conceptually. I've got everything I need for this red line except for the slope of the red line. So hands up. How do I find the slope of the red line? Everybody? Let's go to Mallory.
So you do the derivative of the y equation, and then you do the inverse of the slope of the line tangent to that point.
So let's kind of head down that path. It's a little easier to explain once we get a little further. It's perfect. How many knew we were going to take the derivative of this? 0.2 for Mallory. So derivative. Okay. That derivative you should be able to do in your head now. Hands up. Who knows what I'm going to write here? Think with me. Come on. Look at that. Tell me what I write. You should be able to do that one in your head. So Nick?
3x squared plus 6x plus 7.
How many knew it? 0.2 for Nick. Okay. What's the purpose of this formula? Hands. What's the purpose of the blue formula? Julia? So, really well done. I want to change your wording just a little bit to avoid future possible errors. What you're really doing it's really, really good. I want you to always think of this as a formula for finding any of the tangent slopes on the purple curve. How many knew it? 0.2 for Julia. We need, like Julia said, we need the slope of the purple curve at this point. So we use that xy coordinate. So we have dy dx at x equal -1. Hands up. What does the 4 represent? And again, make sure you're not memorizing this problem. Make sure you are understanding and memorizing the ideas we use, the concept. So what's the -4 representing? Okay, everybody who has their hand raised. Let's go. Hold on. Shoot. Colby, sorry. Yeah, my
What
bad.
is the tangent slope at x?
So over here, the slope of the purple curve right at this point, that slope is 4. So the slope right here okay, on the AP test, when they say slope or tangent slope, they mean the same thing. They don't always say tangent, so if they say slope, they mean tangent. Please.
So for to find the line normal, since it's perpendicular, wouldn't you just do -4 as the...
Close, negative reciprocal.
Oh, so -1/4?
There we go. So the slope of the red line, 2 for Michael. So this slope is -1/4. Okay, how many knew this? Point? How many knew the red one? Point as well. Questions?
Why is it like that?
So we won't do all the details of why, but for this class, because that was kind of covered in the previous class, for this class, we'll just memorize that when one line is perpendicular to another, the slopes are negative reciprocals of each other. So you could, you know, like if one line has a slope of -2/5, the other line will have a slope of 5/2. One line has a slope of -4, the other will have a slope of 1/4. So these are how perpendicular lines are related to each other, one line versus the other. So, 2 points. Question, please.
Me?
Yeah, go ahead, sorry.
So for the answers, none of them are really neatly in point slope form. So what would the actual equation be in point slope form?
So we have everything we need. We have a point that is on the red line.
Would it be
We have a
y?
slope of the red line. So now we're going to do what Matt's talking about. Let's write it down. It's easier to talk about. So we can write it all down. So we write y equals -1/4.
X, plus 1.
Okay. On the written portion of the test, please stop here. Okay. On the written portion of the test, please stop here. You good? Okay. But as Matt said, none of these answers are in this form. So what I notice is these are all in what's known as standard form. They've never tested you on that name, so I don't think it's that important, but that's what it's called. What's important to notice is no fractions, okay, on the x or the y. The x and the y have whole number coefficients. So I want to get rid of this 1/4. So I'm going to distribute first. Well, I guess it really would either way, so I can either just multiply both sides by 4. So when I multiply this by 4, this will still be -1. So then we distribute. So then we get 4y -x minus 25. We move the x, you end up with the answer. Questions? So for this problem, you should be remembering really several different concepts. One, you should have this as a flashcard memory. This will show up in a lot of different problems, not anything even looking like this. You should have in your flashcard memory this picture, okay? Curve, line tangent, line normal, that should be in your flashcard memory. Your flashcard memory needs to include the idea that the slopes here are negative reciprocals of each other. Don't memorize the problem. Memorize the concepts separately as separate flashcards. Okay? Concept that we can use this equation to find the points. We can use this equation to find the slopes. Then we just put it together. So, follow-up questions about this? Perfect. Let's look at the next one. Okay, so this problem uses the same concepts that we just went over. So I'm going to leave this one alone for now, see if you can get through it. If you have trouble, we can talk about it later. So 23 does use the same concept. 20, same concepts again. So we'll skip that one for now. Oh, that's a good one. So this goes back to Unit 1. You have to remember how position and acceleration are related to each other. So, hands up.